In this video, we are going to do 6.02 all-same. All right, so I have the file downloaded and opened up in Racket. So let's just quickly go over it. Let's scroll down and look for the problem statement here. Problem A, notice how the data design steps is done. All right, so they're all checked off. Let's just quickly review it. So list of number is one of either empty, cons number, list of number. We are dealing with self-reference. Here's the interpretation, and here is the template. All right. Write a function all-same that consumes a list of number and produces true if all the numbers in the list are the same. And they give us a nice set of examples here, right? So cons 3 of empty, right? There's only one number, but in a way, all the numbers in this list are the same. Okay, so that should produce true. And likewise, what about this, right? All same, cons 1, 1. Yeah, these two numbers are the same, right? So produce true. 0 and 1, these two numbers differ, and they're not. This list does not have all the same numbers, so produce false. And here's a hint: use second, right? Okay, so pause the video and try to work through this on your own. Move over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. All right, so signature all-same consumes a list of number and produces a boolean. All right, produces true if all the numbers in the list are the same. So let's stub this out. All-same consumes a list of numbers, so we'll call the parameter num-lst. It produces a boolean, so let's just use false as the dummy value to run against some examples here. So all same of the empty list, right? It's kind of not clear what this should produce, right? So let's just say false for now, right? So check expect all same haul. Okay, all same haul of, let's do a list that's one long, so con 3 empty should produce true, right? Because all the numbers in this list are the same, even though there's only one number in this list. Okay, so let's just keep copying and pasting these tests down here. So check expect all same of 1, cons 1, 1 empty, right? All the numbers are the same in this list. So produce true, and then cons 0, 1, like so, right? Should produce false. Check expect. And let's do, one with 3 long. Just write 2 more examples for fun. All same of cons 2 on the cons 2 on the cons 2 empty, right? So, whoops. All right, so this should produce true because all the numbers are all the same, right? But what happens if one of them, just one of them, let's say it's, sure, in the middle is like a 1 or something, right? Well, no, they're not all the same, right? Because they're not all 2s. It's 2, 1, 2. All right, so let's just run our test against like the stub here. Make sure there are no syntactical errors, just mismatches and differs. Comment out the stub. Let's just grab this, something that consumes a list of number. There's a template for that, and rename this all same ? Okay. So now really pause the video and try to work through this on your own. Hopefully this should be all the mental scaffolding needed for all same. I'm going to go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. Okay, so looking at our examples here, we chose false here in the empty list. So let's just write that down. Like so. All right, so now comes the hardest part. All right, so we need to compare, let's say, 2 numbers, right? Because, all right, let's actually focus on the 1 length long test first, right? So if there's one number in this list, right, we have to reduce true, right? So what this indicates is that we actually need another choice here, right? So if there's a 1 length long list, we have to produce true because, that's just this weird case. That's a special case, right? So when there are special cases, you usually have to do a condition, right? So we can do an if here, right? So if let's say this list is 1 long, right? So actually this since this, does something with the first of the list, right? We want to check if the list is one long, right? We don't want to do something to the first of this list. So what we need is another base case here, where we check the length of the list. All right. And whether it's 1. Right? So equal 1. False. All right? Because that satisfies this test. There's no other number to compare it to, right? There's only one number in this list. So it's a special case, right? In this branch. All right, let's do one that's too long, right? We have to compare 1 with the other one, right? So how do you get the second number though, right? Because we're only given the first of the list right here, right? And in this case, it's 0. And then in the next recursive call, it's going to be 1, right? But we need access to we need to be able to look ahead to the next element of the list, right? So what we need, again, is this hint right here. Use second, right? So we need the second of the number list, right? All right. And now we can compare them, right? Since we have 2 numbers, right? So in this case, we're going to write first is going to map to this first one, and then the second will map to the second one. And in this case, right, this other list of 0 and 1, first of the numbers list is going to be 0, and then second is going to be 1, and we need to compare them, right? So let's compare them and make sure they're equal, right? Because that's what we need. We got to make sure that all the numbers in the list are the same, right? So this produces a Boolean, and we need something, right? We're just focusing on the 2 long lists, right? Disregard the 3, right? We're just going to prove it for the 2 list and just assume that it works for a list of any length n, right? Assume that it fulfills the purpose statement. Okay, so since this comparison produces a Boolean, you may need to look into combinators that consume and produce Booleans. In this case, I know that we need an AND, right? Evaluates the true if all the expressions are true, right? If any expression is false, right, it evaluates to false, right? So again, that's what we kind of need here for all same, right? All of them have to be the same. If there's at least one thing that's not the same, then we produce false, and that's what AND is, right? We need that as a combinator. What do we want to AND this with though? Well, we want to AND this with the rest of the list, right? A recursive call to all same that we will assume will work for the rest of the list. So let's just run this code here, and looks like, this test is failing, right? A cons 3 empty should produce true, right? So why is that? Oh, looks like I got the branch, here wrong. So this should just produce true. I don't know why I wrote false there. That's that, test fixed. And looks like all tests passed, like so. All right. So now let's do the last step, test, review, and refactor. All right. So looking at this code, actually, right, this base case actually doesn't make sense, right? Because there actually has to be one number in the list, right? In fact, let's just comment out this base case and see if it runs, and comment out the test that involves this empty case. Comment out the case of the empty, checking whether the list is empty. Just run it and see if it passes all these tests. And so they all pass, right? So we don't really need this empty, checking if the list is empty or not, right? This is the base case. The base case says that the list has to have at least one item in it. So yeah, this is actually the base case. So we don't really need this test. And likewise, we can alter the data definition itself, right? The data definition is kind of wrong here, right? We only can check if all the numbers in the list are the same if there are numbers in it, right? Kind of really doesn't make sense for it to, check all same on the empty list. So we can do cons number empty, right? So this is a 1 length long list, right? We replaced empty with a list that is 1 element long. And this is a list that is n element long, right? So however long you want the list, that's what it'll be, right? Like so. Anywho, I recommend you use the stepper, and also, again, write things down in table format to see a bird's eye view. And, if you're stuck, comment out and debug. Nonetheless, submit this into Handin. Make sure you pass the greater sight test. All right. Anywho, that is about it for this one, and I will catch you in the next one.